Hello all, my name is Prayag.
And my name is Dongyun Lee.
Today we are going to learn how to operate this DIC system. So this is the general box for the DIC system, and we need to open that, and there are some different items over here. First one is an controller. We need that, and then there is this two camera system from La Vision, and there are two lenses, and for that controller we have these electric cables, and then these are the two stages where we need to keep this camera, and there are other lenses that was also available here, and these are the lights we need to keep, and all these we going to explain how to set these up.
So for assembling the camera lenses, it's quite a bit of a process. First, when we're taking our cameras, there's this little black piece on. This nice and easily screws right off. So you're going to screw that off. Once that's off, careful, you don't want to touch the lens itself. We're going to take our C adapter. So when we take our C adapter, it should screw right onto the lens itself. From there, we're going to take our actual lens, pop off this bottom section, and from this top, just squeeze the two sides. Comes right off. From here, you're actually going to rotate counterclockwise, so just keep placing it until you get a piece, and then once you get a rotation, it should be pretty snug. It may not click, but it's snug that you can feel that it won't fall off. From there, you take this little adapter ring. We're going to take the adapter ring, place it onto the front of our lens, screw it in slowly and gently. This doesn't need to be more than slightly hand tight because it is quite hard to get off at the end. Once that's on, we're going to take our blacklight lens. Be careful with this lens. This lens is the most expensive piece. So we're going to take it out. From here you can see threads. This threads straight onto the front of that adapter that we just had. And once that's connected, we can place it onto the railing.
How to attach this LED light on this panel. So you can see the bottom part of this light, and you can just fix it over here, but here in this you need to see this section over here, and you need to just remove this and just fix it over here, and now it get clamped. So make sure like it is completely fixed, and while releasing you need to just remove the bottom part. You need to just remove that, and you can remove this LED light. So this is how we assemble all the parts in this stand. Make sure that spirit level somewhere it's on the middle. So coming back to this main control panel, where we are having these ports, output ports of LED1 and LED2. It goes to this LED1 first, and then LED2 second over here, and then we have this camera 1, this signal connections and the power cables over here. It goes here somewhere in camera 1. It was specified over here, and this camera 2 over here, and other than that we have this port 1 and port 2. It goes, the connection, it goes to this laptop.
This is a setup where all the hardware modules of the DIC along with the laptop are connected via cables. To turn on the system, we should press the power button. Now it's turned on. For open the laptop, there's a password. The password is La Vision, the same spells on the screen, but all small letters. Now we can enter the laptop, and for open this software, we need a license with the dongle. So this is the USB dongle. We should insert this USB. If you press retry, we can figure out the license, and we can open the software for DIC system.
So once we are ready with this tensile coupons, we have three different methods for the speckling. First one is the pen, second one is the fluorescent paint, and third one is this ink pad. For the ink pad, we are having this number of different sizes, and for that we have this ink pad over there. We need to use that for the speckling, and and after that we have these UV light as well to check each patterns. Checking the pattern with this 0.4 mm fluorescent pen, what we need to do in this particular sample, we need to make this pattern over here, and make sure you need to check with this UV light. Make sure you should make this mark over this gauge area. Now we want to do the speckling with the use of this spray, which is a fluorescent paint, orange fluorescent paint. Before making a spray, you need to spray somewhere here initially, and now I want to spray some in the sample. How to do that? So something with this distance you need to spray, and you can see the sample over here, it got sprayed now, and all the pattern will appear in this sample. We need to do the speckling with the use of this stamp, which is 0.007 inch of stamp. We need to hold this part over here, and then we need to just roll it in this ink pad, and then the sample over here we are having, we need to just check over here, and then we need to press it onto the surface of the sample. So this is the Instron 3367 universal testing machine. So we need to use this for tensile testings. So to operate this tensile testing, so we need to just switch it on first. So in the back side of this machine there is this switch button. We need to make it on, and you can see from here there is this power light. It gets on over here. From the back side you can see that switch button. Now we need to turn that Blue Hill software on. For that we need to use the system over there. So for the tensile block you need to use this clamp. Make sure you are using the proper clamp. So for here you need to, if you see, this is written over here 0 to 6 mm. That means your tensile sample is having a thickness that might be in between 0 to 6 mm. So we are using this tensile which is having a thickness of 5 mm, and we are using for this clamp. So we have some connections over here, and we need to use this extensometer. Once it is done, the extensometer is now connected over here, and now here we need to use this universal Blue Hill software. So once this is open, you can see with this Blue Hill universal software, it shows a different method: test, method, analysis, and admin. So for that you need to use this test method, and now you can see if we are using the previous samples, so we need to use that particular program, or if we need to create a new program over here, we need to create it. We need to click it over here. And now you can see here Now this test we can do, it will move up and down. It will not move unless and until we open that software, and make sure like this should be above this line. Now since we are using this 50 mm duplex stainless steel sample, so we need to use this method, 50 mm sample DIC or this DSS 2205. Need to double click over here, press OK, and all from starting we have this tensile stress and strain measurements that comes over here, and here we have a different sections, that is a method where you specified what are the test types over here, and then what are the samples. If you are using number of samples, you need to put that in the inputs, text it, and then specimen. It was already specified what is the geometry of that specimen, width, thickness, what are the length over here, and it was mentioned over here, and the measurement, what measurement we want after the test, and then there is this calculations, it will calculate automatically these particular sections, and then the test controls, strain, pre-test, and then we need to extract this data over CSV file. So this program is already created for this 50 mm long tensile sample. And now before doing the test, when we are clamp this sample over here in this holder, make sure like we need to, right now it is moving with this force and displacement, we need to make it balance all.
We put calibration plates on the holder of the tensile test machine, and these plates will help to focus and do a calibration of the DIC machine.
So once you remove the calibration plate, now you need to fix the tensile coupon in the holder. Be careful, you should not touch on the surface where it has this speckling pattern.
Before doing the calibration, I'm gonna explain about how to control f number and the focus on the lens. So this section is showing the f numbers, and this part we can operate and control the focus of this camera. So we usually start from the lowest number of f number. When you make a connection with laptop and the DIC hardware system, you can see this screen on the software. In the top and the left side, there is a hardware button. Clicks the hardware button. The software will gonna show this screen. So what we can do on this screen is connecting all of the hardware to identify this software to understand and connect with the hardware. The controller box and camera 1, camera 2, and there's a light source box as well. As you've seen before, there's a 2 LED, but just one box is enough to control the LED on this system. So if you want to change the items, you can click the items on the list and bring it to the center. And you can connect with this green one. For us, we are using the camera
which is named Imager E-Light 5M, and Light Source 1 linear LED illumination units. So after you bring those boxes, you can press a full hardware initializations button. Yeah, everything is connected now. Now go back and add a new workspace. What we usually do is go into DIC project, and there are so many folders already, and we can make a new folder. Yo. Yeah, man. And then we can create new project. And there is imaging and there's strain. We're gonna start with strain. And project name, test 1. Now we are ready. Now we are ready for measure the strain with the IC system.
Once your project is created, you're going to go to the recording tab. From the recording tab, we are able to see on our right side here, this is what our cameras are seeing. Down here, you can switch from your F values. F0 stands for your first camera. So when you looked at the cameras, they have 1 and 2 labeled on the top. F0 stands for 1, F1 stands for 2. It's a little confusing. Over here, we have our controls for our lights. Currently, it's selected for light control when recording. This is light control off, and then this one is light control is on at all times. When our lights are on, it is producing a flashing light coming from the DIC system. Usually we're going to keep it at the light control as recording. Below that we have our light value. This will increase the light that the cameras are able to see. This is better for when you have speckling that does not fully match and you need to see better on the background of the camera. Below that, we have the next important thing is our image rate. Image rate is best to leave at 2 Hertz. Recording is underneath that, so you can choose between time, how long you would like it to take, or how many images you would like it to take. Make sure that each time you create a new image or take a set of images, you rename it. It will always create a new name for you, but for standards, it's best to rename it every time. When you're ready to record, you can use the recording tab down here to start recording. You can always pause or it will stop recording as you need. For aligning the cameras, we go to our first camera. The best way of doing it is over here on this right side. There is this little magic wand button. We click that magic wand. It allows us to see better into the view. And then from there, Dongyun is adjusting the cameras, adjusting the focus to see better, and aligning it so that we can see. Currently, we have the calibration plate in front so that we are able to have an idea of where we're aiming the cameras at. It's best to have the whole image taken up by one. And then once that is done, we will complete it similar for the second camera. Once you have the cameras aligned, it's best to look closer. You can zoom in here and see how the camera is looking. From this point, we can see zooming in and out using the focus that our camera is pretty good. So now we will switch it to the second camera and do the same thing. Like I said, same thing here. We're going to zoom in on the image. Best to see how our pixels are looking, see if the adjustments are needed. It's really good with calibration plate because you can see the numbers here as a good indicator of how well your cameras are focused. Now that we've got the cameras aligned, as you can see between the two cameras on the right side, both of them are in view with a good description of all of the dots plus the words on it. For the calibration over on our left side, I have renamed it to calibration. Doesn't really have to be anything specific. set it to 10 images, and then make sure your camera and light is set to recording. Once you have all of that, you're able to hit record. Once all the images have been taken, you'll get a list over here. You're going to go up to the top left, hit the back button here. I'm going to open this up so you can see. Now you can see in our current project, we have the tutorial calibration here. Once we're there, we're going to go to our left ribbon here on calibration. We want string calibration. Once that's been selected, everything should be listed properly here. You want to make sure it's selected as 3D for the calibration plate. Model is a pinhole. It is 0 distance because we have it set where our sample will be set. So make sure all of that is accurate to where you have your camera. If you have it behind where your sample would be normally listed, make sure you choose that selection. In this case, we have it where ours is, so it's set to 0.
Please make sure to choose calibration plates. What do we have? For us, we have 0 to 5, 3.3 is our calibration plates. So select this number and hit the start button. And now this software is doing a calibrations. That's done.
Yep.
Okay. After clamping the sample, we're gonna run the DIC with pencil test, and for these sections we click the time and we input 1200, which means 2 minutes. We insert the times value and hit the record button.
From this system, you need to do the balance all and start the test.
There's sample breaks. We press stop button. So everything is recorded. Go back.
Once the tensile test has broken, you're going to go select tutorial tensile test, go into the string selection. From here, you'll see your collection of images. You can go through your images collection down here. You can watch the video. You can speed it up based on however you need to using these buttons down at the bottom. So you can see from tensile test, you can see it being pulled all the way through. From there, we're going to go to our first image. We're going to create an auto mask. This auto mask should be in the shape of your tensile test. It doesn't need to be perfect, but it should shape it as best as possible. This here is our coordinate system. I'm going to zoom on this. So once you've done that, you have your coordinate system here. Make sure this is set to user defined. I'm going to set it in the vertical direction. You're going to draw your line vertically, and it'll align it to the side of your sample. Based on your sample, it doesn't need, like I said, doesn't need to be perfect, but it should be as accurate as it can be. And then it should be placed in the center of your sample, along with the origin, which should go the dead middle on that coordinate axis line. Once you have that correctly made, double check your mask. From there, we're going to check our seed points. Our seed points are going to be based on the grid size. The grid size can be connected from here on the right for that show hide grid. You'd like to see a couple of these speckles. This seems to be slightly over speckled, but you'd like to see a couple of these speckles per grid size. For this, I think we have about 4 to 5 is what you're aiming for. So if we're looking at this one, we can count. There's about 5, maybe 6 in there. That would work overall. based on what you see there, you can change your subset size or your seed size here. And if they do not align properly, you can delete them or manually place them and then auto do it again. From this, it looks like we have all of ours down in a good line. So we're going to hit start.
So the strain analysis is completed.
So this screen shows the final results of analysis of the strain. Then we're gonna show the deformations of a tensile test coupon and this DIC software analysis the strains depends on speckles distance. So if you increase this number and the videos plays more fast, and there's a match button. If you click this, then we can see the difference of the strain. This button shows the optimal coloring map. So if you hit this optimal color map range, then it is mapping the strain colors automatically on this pencil test coupon, and select the optimal colors to shows the difference and deformations of the strain. So this is the final results, and hit go back, and the last step can be a processing and export. If you click process, you can see several options that you can analyze the results. So let's show just one of the option. For example, let me show you to rotate the result with this block. So if you see, I select this rotate block and insert between input and output of the boxes. Then this is the input data, and it shows the rotated results. And if you're gonna click, then they're making an ordered result here. And if you click this, you can also choose image options, and also we can overlay grids and blending, those kind of things. This is tutorial video, so I'm gonna just stop here, and let's check how to export the data. So here is a parameter that you can choose as a result. So we can choose the results as image file and also video files here. And there's a resolutions, and we can also select the storage. So if you hit the start button, you're gonna storage all of the data into the selected folder as well.
This is the end of the explanation, and thank you for listening.
Thank you.